been around in the data and let's say environment for a long time, and like 12 years ago I wrote my book about SQL Server when two other my colleagues, we spent vacations together, 3 months writing a book, and it's really great book. I think I run my own blog on codingfamily.net, and what I do every day, I just work with data on very different levels. So when you think about data, and we should start with something which is called classic data warehouse, because this is where the entire journey starts. And probably you have ever heard about how the classic data warehouse looks like, and it looks like this, what you see on the screen. The bottle is like a table. Each bottle has its place. It's a very tidy place to live. But if you'd like to put another bottle in this beautiful room, in this beautiful data warehouse, it really takes time to do so. And usually we cannot say that running a classic data warehouse, it is not a very agile process. It's rather like a classic waterfall process. So if you think about this, this is not what you are expecting from the times we live right now. So in classic data warehouse, you have to be aware that if your data warehouse grows over time, you need to pay for storage and CPU, and this is very costly. And the correlation is that the more storage you need, the more CPU you need to process the data. And the problem is that this is very costly. At some point, you need to store the historical data as well, for example, for 10 or 20 years. And expanding classic data warehouse, you need to pay upfront. So you just need to buy another server room, put $500,000 into it, and probably at some point of time, and I have very cool slide for it, you see at some point of time, you will spend all your money on storage and compute. The compute will be full. Sorry, the storage will be full, so you need to buy another data center. That's why we really try to move into cloud. And this is not the only reason. Of course, cost is one of them. But we are not living in perfect world, which I already tried to show you, but we live in something like this. And this world is totally different. And it's not different because you might probably think that this is a mess. From my perspective, and I am really crazy about data, it's not a mess. It's a very typical situation we have in every company, because what you see is that there are a variety of data sources. Each bottle in this lake, and the lake is like a storage, is very different data source. And you have a lot of them, and companies have a lot of them. And the question is how to very effectively take data from all data data sources you have, and look for insights in the data. And this is a pretty complex task. And you can spend months, if not years, trying to bring data from such different data sources and give value to those data to make sure that at the end the company see the value. And this was tough previous times, but now we have the support from what Azure Cloud gives us. And what really came into the light just recently, it could be like a few weeks, is that we can build a modern data warehouse. We were able to do this previously as well, because Azure Synapse was previously called Azure Data Warehouse, and like for a few years we had also Azure Data Lake. But now we have the complete ecosystem. So the most important part when you think we should start is the Azure Data Lake storage, because this is a really game changer from what you've seen so far in the modern data warehouse. Sorry, in the classical data warehouse. Because in the classical data warehouse, your storage is tightly connected to the compute layer. Here, Azure Data Lake storage is the storage which is completely independent of any compute engine. So the goal is that this data lake, which was manifested here on this screen, you see, so this data lake storage is able to take data in its native format without any transformation, without reading the schema. So it's very, very fast. It's extremely fast because you can put literally everything here. Those information you put, it could be small, it could be big. There is right now, I think, technical limit like 4 terabytes on one file. But you know, technically speaking, it's not a limit because you can divide file into smaller parts. But this data lake storage works very effectively if you have many small files, like billions of files of size 1 kilobyte, and the same effectivity and the same power you have if you work with big files. And this is not that easy to achieve if you try to build your own storage. Believe me, it's not that easy. But then you have to think about how you should fill data into the data lake. And to do so, you see Azure Data Factory on this slide. And Azure Data Factory is really the data integration at a scale. So you can really put data from other clouds like AWS, from, for example, S3. You can have connection to hybrid connection, for example, to Oracle, to Postgre, MySQL, or whatever engine you think it could be necessary. You can also connect to, for example, to Salesforce, to web service from Salesforce. And there are like 100 connector ready to use. So without coding, without writing any line of code, you can connect to a data source and grab the data. And you can read literally every type of data into it. But you know, this is only half of the battle, because then you need to perform transformations. Because if you don't transform your data into some valuable format, maybe you need to do some pre-processing, then, well, it will not be, you know, we always have to perform some transformation on the data to make sure that we can play with data that are really important for us. Once the transformation is done, we can load the data to Azure Synapse Analytics, which is data warehouse plus more. And I tell you what the more exactly means. But you know, the transformation, we can use very famous Azure Databricks component, which allows you to transform enormous number of data files at once. But this is not all. In Databricks, you can also create, for example, machine learning models and perform some kind of predictive analytics on the fly. So in this modern data warehouse, we should see 4 main components, as you see on the screen. So this is the Synapse SQL, and I'm going to show you the Synapse SQL right now. So it is really generally available, and you have 2 choices. And really, this is the game changer. There nowhere in no other cloud you can see something like this, that you can really buy, let's say, normal data warehouse. It's of course cloud data warehouse, which is called SQL Pool. Previously it was called Azure Data Warehouse, and you are going to pay for the usage. But if you don't want to do this, you can just pay as you go, and you will be charged by terabyte of processed data. And this is what I'm going to use today and show you today. And this is preview functionality. The SQL Pool is generally available for you. In my opinion, what's going to happen in a moment, like in a few months, it will be the increasing role of Spark engine inside this Azure Synapse Analytics. Because Spark, this is really the missing puzzle, and we are really looking for it right now. And it is right now ready for us. It's integrated, and it's preview functionality. So we believe at the end of this year, it will be generally available. And of course, we immediately put it into production. And then you can build a pipeline. So you can build the entire pipeline I showed you on the previous slide. It's called Synapse Pipelines. And to make sure that you can code efficiently, there is a Azure Synapse Studio, which is also in preview, but it really doesn't matter because I can show you the code right away. So let me switch to the code, because I think the code is really something which you should see today. And let me start from the beginning. This is Synapse Analytics, and this is the Azure Synapse Analytics Studio. But I'd like to show you what we are going to do today during the demo I've prepared for you. So first of all, I'd like to show you how we can work on live data. And we are going to analyze the actual information we have from the pandemic. There is a European Center for Disease Prevention and Control, and they actually publish information every day. And they publish the information in different formats. So you can take the data directly from their site, or you can download the data from Azure Open Datasets catalog. And you can play with those data just to make sure that you can learn how to perform analytic on the real time. So that's what we do right now. We will be using the COVID-19 data lake. This is what we are going to use. But this open data, those open data sets you can find on Azure, also allows you to build some predictive models. So you can also play around with machine learning and AI as well. So what I did, I connected to this COVID-19 data lake page, and as you see, the file is presented in many different formats. And for the sake of analytics, we should always be trying to find a format which is a columnar format. So you know the CSV file is a raw format, also JSON, okay, maybe we can also think about JSON that this is some kind of raw format, but the columnar format is a Parquet file. And why we should use it, I mentioned about Spark Engine, and you know Spark Engine is has columnar format implemented. It's in-memory columnar format. So most of the time, we are trying to use files that are in columnar format, because then we can just load them efficiently into the memory, and they will be processed also only in the memory. This is what I'm going to show you today. So I can connect directly to this data lake. Data lake is just the storage. But what I did is I created my data lake for my Synapse Analytics, and I downloaded the file today prior to this presentation. So you see it's there. But just in case, I'd like to show you my other account, which is called Aircraft. And as you see in the Aircraft, I have plenty of files. And just to show you that you can work very efficiently on more files than one, and usually, you know, we have millions of files in one catalog, and we can process them immediately. So let's start with this analytics, what we can do. Take a look at this query. I bet you have ever seen, you should be aware about some kind of language, SQL language. So probably you have ever seen the very simple SQL syntax like on the screen. So what I'm going to do is I'm going to connect to the data lake from Synapse Analytics directly by using SQL query and read first 10 rows from this file I took from the European Disease company. So you see, I've just started the query, and after a few seconds, it displayed me information. So now I am aware what is the schema of the file. Of course, I can read it in different format. I can just read the schema from the file. But in that case, I just took first 10 rows, and what I can see is that I have some information about when the measure happened, what day, what month, and what year, how many cases we had that day, and how many deaths we had, and also the information about in which country it happened, and what was the population of this country, and what is the continent where the country is placed. So you see immediately how many analytics we can perform on this single file. The file is not big. It has like 19,000 of rows. And believe me, sometimes it's easier to read the entire file that take 10 files, 10 rows from it. So let's perform some analytics on the file. And I'm just going to show you the very basic things which you can do here, but I'd like to show you how far you can go. And that, you know, the only thing that is preventing you is your own imagination. There is no limits what kind of analytics you can perform here. And this next query can give you answers how many cases and deaths we have per a country. And this is just done by on the files we have. So you see the most, let's say, pandemic country right now is United States, with almost 2 million of cases and a lot of deaths in there. But we can go even further. What we can do is we can say, okay, let's take a look closer to the US, because this is the country which, from the data perspective, has the most cases right now. So we can also say that they have a lot of problems there. So we can take a look how many cases they have per different months. And having this, maybe we can do another analytic. But you know, I'm not happy that I have to read the file every time. So maybe I can create my own database in which I will be performing the analytics. So right now, I'm going to create my database. This is what I did prior to the presentation, because it takes a few seconds. So I created this COVID database. And in this database, I have two choices. I can create a view or a table. Table would be better because I would then load file or files. Take a look. I can take all files from a catalog and load them immediately. You know, immediately means that I can load gigabytes of data in several seconds, depending how scalable am I. But this is really what you can achieve. And view, it's like only a wrapper on the file. But you know, in that case, it's enough for me to have a wrapper, because then I don't need to take the name of the file everywhere, and I can get rid of it from my queries. And take a look. Now I can perform a little bit more fancy analytics. So I can go and perform something like this. So previously, I have shown you how much cases we found in US per month. And from this, maybe we can calculate so-called mortality rate. So how many people there died per amount of cases. And we can see how it was per month. And right now, take a look what we have. We see that the first cases in US in terms of COVID, they were registered in January. In February, we have 60, but take a look how much cases we have in March, April, and May. And the mortality rate is like 7% in April, 5, almost 6% in May. And now we have 3.6 in US. And you can say, okay, so maybe this is something, and we are curious even more. So maybe we can do some kind of time analytics, how data from April are related to data in March and how it changes over time. And take a look, this is exactly what we can do. And if you have ever worked with SQL and you know windowing functions, and this is ISO standard, you can perform analytics on the fly. And you can say, okay, what is the previous number of previous month cases? How many cases I have new? So I have, what is the difference between cases in, for example, April and March? And we can do some kind of running total analytics. And we can, for example, perform month over month analytics, like how many percent, what is the growth month over month, and something like this. And you know, it's just pure SQL. I have never employed here any Python code, but I can. It's very easy also to run Python code inside the data warehouse. So take a look. Let's do this analytics. And then I can tell you that this is not all, but take how beautiful we can present data and how many informations we can have just having one file, and what we can see here. So take a look. We can perform running total analytics, so we can sum the cases up to the total case. What we can do is we can also perform cases running total over total cases, and we can see that this is like 33% we have in April, 37, almost 38% we have in May. And this is the running total, so you see we can sum up to 100%. And this is also what we see how the pandemic was, you know, how dangerous it was, especially in March. This is the number of percent it growth month over month, 274,000 persons. Now in June in US, the increasing rate is only 52%. But you know, I have only 10 minutes. I'd like to finish it in 10 minutes. And this is what I'm going to do right now for you. So we just look from the historical perspective. But what if we can take a look into the future? At least we can try. So to show you that also in this data warehouse and just playing with data, we can work a little bit with regression. This is what I would do normally in machine learning model, but I have no time to build machine learning model. I just want to play with data to see if I have valuable information. And you know, the simple thing you can do in that case is to build a model which will be like a linear regression. So if we can do something like this, maybe we can predict something valuable with the data we have, and this is just an example. So our, you know, our function will be then presented like with two coefficients. So we can say that we have coefficient A, which is the slope, like this. So this actually this angle here is proportional to the A, and of course we have the coefficient B, which says what was the starting point. Sometimes we call it gain. And for linear regression, I found beautiful coefficients, and this is the coefficient A, and this is the coefficient B, and this is the factor which say how the data is correlated to the function. And of course, you know that we should be close to 1. The question is how we can find the sum. This is sum over y, and we are predicting y from the x, and y is how many deaths we have, and x is how many cases we have in this simple example. So sum over y, we should find sum over y. We should have sum over x correlated to x, sum over x. Here we have sum x, y. We have number of cases, so we have number of samples, sum over x and x minus sum over x squared. And this is how the A is you can find. Then you can find coefficient B, and you can find this coefficient which is called rho, which describes how good is the correlation. And I have 2 minutes, so I show you how we can play with this in our data warehouse, just to do this kind of analytics, you know, without employing even machine learning. This should be your next step. So take a look. What I do is I'm going to take data from all the countries we have, and per country, I'm going to find out how many cases and how many deaths were in every country. And then I'm going to find the coefficients I shown you previously on my screen, but how to find the coefficients. So you see from that data set, which is our view, I can create a sum over x, and x is the sum of cases. This is how we create sum over y, and this is then the coefficients x regarding to x, x regarding to y, and and y regarding to y, plus number of experiments. And from this, we can also go and try to find out the coefficients of this of our function. So let's play with this. And you see, in a moment, we will have the overall situation in the entire world. And the good thing, I hope, is that we see the mortality rate and how the pandemic works in the world. So, you know, the A coefficient is negative, means that from the entire world perspective, the pandemic is going down because the slope is negative. However, the mortality rate is a little bit more than 6% right now. But you know, from the globe perspective or the Earth perspective, we can say that situation is not that bad because the number of cases are decreasing every day, because this is what this coefficient says to us. And you know, we are pretty, we have pretty good correlation, 92% correlation with our data. But if I take a look, for example, from Poland perspective, is the place where I live. So how this model looks like from Poland perspective, and we say, okay, in Poland right now we have 3.7% of the mortality, but number of cases still is going up. So pandemic in Poland is not yet finished. And you know, this is how you can work with data right now in modern data warehouse. We just built a modern data warehouse. I've read data from unstructured file, I process it, transform it, and build a very simple model just in 30 minutes. And that's all. I could speak the entire day and night about it, but I think Magnus is now showing me that it's really time to finish. So thank you very much for your spending this half an hour with me. And Magnus, stage is yours.
Oh, thank you very much indeed. So I was more nodding to what you were saying, that you could spend that much time talking about this, and I think we all could spend the same amount of time listening to it. Oh my goodness!
You know, it's my work, but it's also my passion. I love to do it for 20 years, and this is what I really like to do. Yeah.
That was very clear. Well, thank you very much for that, and showing us all how you can actually dive into data and be you know, derive real value, almost like real time. This is fresh data, and you're showing us like directions of the pandemic, almost like it was live. It's really, really impressive. Wow. Yeah, I'm getting comments here. Very interesting presentation. Yes,
thank you very much.